Hi there, welcome back to Triplicate, and we're going to have to take another look at the super battery charger tester, which I've been using quite successfully some time, but it seems to have developed a fault. So here we are. I've had it on trickle charge at 25 milliamps for a little while. And it's a single nickel metal hydride battery, so it should be showing 1.4, 1.5 volts, and remember these are in millivolts. It's showing 32,000 some millivolts, and it was on occasions jumping up to showing about 18 or 20 volts or something crazy. So something has gone wrong with the voltage measurement and possibly the current measurement. I'll need to check that. So in this video I'm going to go in and fix this problem. I'm also, if you look here, it's constantly sending out the log, just repeating it over and over and over, sending it constantly, and I think that's on occasion caused problems with the buffer filling up and the USB complaining. So I am going to make that so it only sends it when it's requested, and it only requests it once in a while. But we'll look into that once we've fixed this voltage measurement problem. Okay, and here we have a voltmeter, a multimeter set to volts anyway. So let's put this across this battery and see what it's actually measuring. Yeah, the wrong way around. For what it matters, might as well show it the right way around. So about 1.3 volts, and it's measuring 3.2 volts, so it's not even exactly double. So let us see if we can find what the matter is. So okay, here is the circuit. You may recall, or you may not, there are battery power plus and battery power minus. They're providing the current to charge and discharge, and then there are two sense wires which are connected as close to the battery as possible, so as not to get wrong sense readings, because it's detecting voltages caused by currents flowing down the power wires and small resistors in the wire and the connectors and so forth and so have you and what have you. Anyway, here we are. Oh, that's the dog kicking off. The two sense wires come in and go through an 82K and then to each to two analog inputs on the Arduino via an 82K and a 10K and a 10K. So for instance, A0 is a fifth the battery sense about, and A1 is a tenth the battery sense positive, and similarly the battery sense negative A2 and A3. So we need to see what those voltages are and whether they are correct. That's, I think, our first job. And so here we have a meter on a ground, and let's see what is across the battery. Now remember, it's on trickle charge, it's charging, so we would expect the positive to be nearly 11 volts. It's running off a nominal 12 volt supply, and the bottom to be 9.3, which is whatever, 1.5 lower, thereabouts. What's the battery? What's across the battery? 1.32. Right. So we will check those voltages where they come into the board here. So that's battery sense plus 10 and some, battery sense minus 933. We like it. So A0 is pin 3 is that one, and that should be about a fifth of battery sense plus. About a fifth of 11, which is 2 and some, which it is. And this one should be a half that, so it should be 1 and some. Yep. So the next one should be about a fifth of 9.5, which will be just under 2, which is 3 volts, which should not be. It should be under 2 volts. And this one should be 0.78. 0.8, that's not entirely right either. So there's something funny going with the battery sense minus. So looking again at the schematic, we want to see what's happening at R4. R4 is the 82K. So R4 is this one. That end of R4 is 2.7. No, we're looking for just under 2, and that should be 9.3. That's 2.7. Is it? Come on. Let's get a probe on that. Which is wrong. And is that what this is? 2.7. Just under 1, which should be half that. What do we suppose is causing that? Okay, so I have taken the battery charger board off the top of the Arduino, and we will check the values up these resistor chains. The resistance values, that is. I'll just zoom in. A reasonable view of what I'm doing. So this is ground. Let's do the battery plus one. We kind of knew that worked okay. We did, we tested it and it worked okay. So if I go to here, I get no ohms. That's grounded, but the bottom of R3 is ground. The top of R3 is a resistance through R3, which is, trying to do this without putting my hand in front of the meter, 10k. So that's the bottom of R2, which is 10k, as we would expect. The top of R2 is 20k, two 10ks, as we would expect, right? The bottom of R1 is, come on, 20k, it's connected across there, and the top of R1 is 20k plus 82k, 102 odd k. Happiness. So let's try the other one, the problem side. So the bottom of R6 is ground, as we would hope. Top of R6, 10k, as we would expect. The bottom of R5, also 10k, as we would expect. The top of R5, come here. Stay on. Can you see the meter? Yeah. 20k, as we would expect. So the bottom of R6 is, whoops, open circuit. So between the top of R5 and the bottom of R6 there is a problem. So let us see if we can find it. Okay, so the limits of what the camera will do here, and if I knock anything it'll bounce around all over the place, so please bear with us. But if you look at that pin, you can see the solder is not actually wetting the pin, i.e. here we have a dry joint, which I believe is the cause of our problem. So I will fire the soldering iron up, dab some solder on it, and we'll see if it's cured the problem. Okay, the first thing I am going to do is apply, hopefully, a little bit of extra flux. There we go, got a bit on. Hard to do. Try and aid curing a dry joint, and I put the camera in the wrong place. Right. One soldering iron and one solder. I'm trying to solder in the camera. That looks good to me. So let us flip it over and test the resistance of that resistor chain. Okay, so let us see if we have cured our problem. So there's our ground. So this end of this is resistor is come on. Ground also, that end of that resistor is 10k. So this end of this resistor should also be 10k. This end of this resistor 20k, and fingers crossed this end of this resistor is open circuit. So that has not cured our problem either. We haven't cured our dry joint, or or what? Okay, so the next thing we look at is, you probably can, you see I'm looking at the screen on the camera, which is a bit not very brilliant and absolutely filthy as well, which doesn't help. So it'll probably come out okay on the video, but you see the solder, I've only soldered the bottom, and the solder come down the hole. These holes are through plated, are plated down. There's plating on the inside of the hole, so the solder's come down the hole, and that one also, whoops, you see the solder's come down the hole, but this one, which is the one we're worried about, there doesn't seem to have any solder come down the hole. So I'm wondering if the through plating is no good on this hole. It's an actual PCB fault. Alright, but we can cure it by simply soldering the top of the board as well as the bottom, which will connect the two layers, because the connection out of here comes underneath the resistor and across there. So if that is not connected to the resistor, it won't work. Come on. Again, I'm trying to do this in the camera viewfinder. That looks alright. Okay, so shall we try that? Okay, right, let us try again. So we're pretty sure when we get to there we should have, mind my hand, 10k. Come on, better get the probe to sit on reliably. We get to here, we should have 20k. We get to here, we should also have 20k, yippee! And we get to here, and we should have, if I can get there, 102k. So we should now be good, and that was it. A badly through plated hole. That's what you get for $5 a board PCBs, I guess. Right, so we'll now reassemble it. Get the old check they're all lined up and all in the holes they're supposed to be in. There we go. You can't see what I'm doing, can I? Because I'm zoomed in too far. We will connect up the battery, connect up the power. I've lost that. Oh my god, there's the power. Connect up the serial. Right, and we need to fire up the application again. Okay, so we will load our battery data again. We will send it to the charger. We will hit run. There we go. The relay's clicked in, so it's in charging mode. We will put, can we see that? Let's shift things so we can. And we will check. We check the A to D's, right, millivolts. So 2 volts, which is about, again, it's 10 and some, and 9.3. 2 volts, fifth 1 volt. 1.8 volts, 0.9 of a volt, 900 millivolts, yeah, so this should be about half again. So that looks to be working alright. Oh, that's the wrong one. Right, 0.9, 1.8. Oh, come on. 1 and 2. So we'll now have to leave it running till it starts sending some data, and we will see how that goes, and I will bring you back. Okay, that's been running overnight, and it seems to be doing what it should do. It's not thrown out any unexpected voltages, so I think we've fixed that. So the little software fix we're going to do, you can see here, so this on the left This is the latest reading, which is fine, which is fair enough. One of those happens every 5 minutes, but in the meantime you can see these are the messages as they come in, and it's just throwing the log out over and over again constantly, and that's caused problems with it filling up buffers in various places. I don't know whether this, we might try this. We try this. So we'll turn it off and we'll run it again. Nope, it's worked this time, but sometimes it can just say, oh, the buffer's full and I can't do anything. So what we are going to do is get it to resend the whole buffer when it gets one new reading, and then when we do anything that requires it to be saved or something, so if we save it, save log, battery charger, test results, $16 I believe it is. Yup. And that's whatever the date is, 14/04/23. There you see it asks for it, it resets it all, and it'll ask for it again. So I shall do that and bring you back and show it working. We'll wait for this to draw and then we'll have a look and see how good this battery is. There we go, drawn it all. Action, analyze. Alright, so that's 1689 at 0.7 ohms, so the resistance is a bit high. Usually when it dies under load at the end, that's a symptom of that. And I don't think 1689 is very good. It's supposed to be 2700 or something. So I think this battery might be one for the recycling. Okay, I've changed the Arduino code to run in fast mode, so you can see here, it will in a minute, every, I don't know, half a minute, 20 seconds, it's ticking up a new value, and you can see the values have just been sent out as before, just looping round, constantly sending out values. So the first thing we need to do is go in the Arduino code and only send out values when they're specifically, log values, when they're specifically asked for by the PC end. So let's have a look at that. Okay, so that seems to be working alright. It's running in fast mode. So, so hang on, there we go. So if we wait for a new reading to come through, 20 seconds. There we go, and it's reloading all the log, and I'll let it run around again, and we should see it adding to the graph. There we go. There we go, and it's added a reading to the end of the graph, so that's fine. And I've added this, I sort of added it for test purposes, but I'll leave it on, and that will redraw the whole lot. So time to put the Arduino code back up to, or down to normal speed, and we can put another battery in and try and see if it's working, still working as we want it. Okay, so here she is. It's been running overnight and some with the battery in, and As you can see, it's charged the battery up, discharged it, and it's charging it up again, and it's all working fine. So I think we're going to call that a success, and I am now going to go through these batteries there, which I've been waiting to test, and don't really plan to do any further battery investigation or development on this for now, even though there are some bugs in it. But if I fix them, I'll fix them off camera. But I do plan to hack into that and see what makes it tick, see what sort of charging regime it uses, and shall we, if we can, I hope that comes out in the camera, but that one is flashing with no battery in, and flashing red means there's a fault on the battery, or it doesn't recognise the battery. So there's always been something wrong with that channel since the thing was virtually new, and it is quite a lot of years old now. So that's an upcoming video, that's one for the future. But for now I think that's it on the super battery charger. So that's it, I'm going to call it a day on this video. We did what we came to do, we fixed the problem on the battery charger circuit, which was a dry joint and or a bad through plated hole, and I improved the log getting circuit software, so it's not throwing out data continuously and sometimes upsetting the USB buffers. So yeah, a successful video, and we'll see you on the next one. So for now, it's goodbye from Triplicate. Goodbye.